And is it correct that this is the first one? No, this is not the first one. More Max Min has the sweaters question first. I just have to find it. And of course, I don't have it here. Let's see. Maybe I have it up here. Yes. Oh, this one I've already got printed out. But we'll explain it as we go. This is very similar to the last question, but the last question, I hope you understand that profit is the difference between how much you sold something for and how much it cost you to buy it. The school, when they sell something for $20, they don't make $20. They only make, a business only makes the difference of what they bought it for compared to what they sold it for. So in this question, it's saying that these sweatshirts were $20, but it cost the school $10 to buy. Now, what's the maximum profit? Should they still sell them for $35? It's going to make a difference now, right? So let's look at an example, okay? Let's look at number sold. Let's look at the profit now. If you sold 300, how much is the school actually making? Okay, 3,000, because they're only making $10, not $20 anymore. So their profit is 3,000. Cost is still $20 here. But the revenue, the amount of money they make, or the profit from one of them, is only $10. If they increase it to $25, they increase their revenue or their profit. This is profit too as well. This is total profit. Their profit on one is $15, and then they would only sell 270. 15 times 270 is 3,000? 4,050. Thank you. You make more, so that's better. So it seems like, okay, we should increase the price to $25. So what we have to do, just like before, start off by using words. My profit is the individual profit times by the number sold. Then we have to go, and sometimes a chart helps us see what we're going to do. We start off with $10 and selling 300. And this part that I underlined in green is always going to be, in these profit questions, they always give you a starting off point. This one it says $20 each, 300 will buy it. So that means that 300 will buy, you'll make $10. That's your starting off point. Then they tell you what happens if you increase one, the other one decreases. So if we increase by $5, that's why we have a plus 5x. And every time you increase by $5, you subtract 30 people. So this is very similar to the last question that we did, with the same pattern happening, but now we're going to see how this cost affects our question. So we multiply this out, and we get negative 150x squared plus 1200x plus 3000. Again, that's a parabola that's opening down. Because the a value is negative, we know we have a parabola that opens down. We are looking for that maximum. The y value will be the maximum profit, and the x value will be the value of x that gives you that maximum. So we have to complete our square and change to vertex form. Factor out the 150. So you take the 150 out of the first one and the 1200, the 3000 stays outside the brackets. Draw a space for each number. The minus 8 is a hint. You know this is going to be minus 4. Minus 4 squared is 16. And then negative 150 times 60 is negative 2,400. So we need to add 2,400. And that tells us our vertex. So we know the maximum profit is 5,400. There needs to be 4 times that you increase the price by $5. So that means you'd be selling them for $40 now. And only 180 people will buy. So kind of cool questions because they're actually seeing what's the difference, right? We have to figure out, we could, for our volleyball tournament, we sold things at our volleyball tournament. We could have looked at how many did we sell, should we have increased the prices, even though we would have sold less, but made just as much money, okay? Now, that's if you want to make as much money as possible. If you're setting up your canteen so people are happy and have things to buy, then you might set your prices differently. So all of those things you have to take into consideration when you're doing this. Okay, was everybody done? I can go back. Are we good? All right. Let's do the bus one next. We want to find a maximum revenue. So we need to make an equation that is revenue equals. Revenue equals, what are we doing here? We're selling bus tickets. So we've got the ticket price multiplied by the number of people. Does that make sense in words to figure out how much money you're going to bring in? Whatever your ticket price is, multiplied by the number of people. And so when we make our equation in algebra, do they give us an initial ticket price? Yes, $1. And then, how many people will take the bus? Initially, 20,000. So if we kept it at $1, the city would bring in $20,000. But for every time that you lower the price by 5 cents, so I'm going to take off 5 cents X amount of times. So down here, I'm going to explain that X equals number of times price is lowered by 5 cents. And you notice I made a mistake. What was the mistake I made? Anybody see the mistake I made? I have to erase something. I lowered it by 5 cents.
No, by half.
I lowered it by 50 cents. So we need to add a 0 in there. That would be lowering it by 5 cents. And what happens if you lower it by 5 cents? More people take the bus. So we go over here. Every time it's lowered by 5 cents, 2,000 more people will go, and we have the following equation. Multiply this out. We would get 20,000, 2,000, someone double check my math. What is 0.05 times 20,000? That's 1,000, so that'll be minus 1,000x plus 2,000x. That's good. And that will be 100. Perfect. So now if we rewrite this in the right order, with the x squared first, we can factor out the negative 100. That gives us spaces to work with. So this changing to vertex form keeps coming up over and over again. It's very similar to the completing the square form we did in chapter 3. And now we're doing it a lot to get the vertex form in chapter 4. The hint is the x squared minus 10x. So the minus 10 tells us this has to be a minus 5. If you multiply that out, you would get a plus 25 in here, but we don't have a plus 25. So we have to compensate and subtract on this side. But what have we actually done? We've actually already subtracted 2,500. So we're going to have to add 2,500. And so we get a vertex of 5 and 22,500. What does this mean? This is the max revenue. And this is the x value that gives you that. So now we can go back to our words and write out everything that we know. We can say what the ticket price is. The ticket price means you need to subtract 5 cents 5 times. Ticket price would be 75 cents. The number sold, you would have to add 2,000 5 times. 2,000 5 times would be 10,000. And you can check, if you do 30,000 times 0.75, you get 22,500. So here, the bus company was selling things for too much. So they needed to lower their price in order to get the maximum revenue. So what I'm going to do for these next ones is I'm going to get them set up for you. Okay, we've got 1, 2, couple more, and then I'm going to leave time for you to do the completing the square on your own. I think I have the answer keys to these ones, so I'll put them up on the video so you can check. But here's another example similar to the profit ones. If you have a section of land to build an orchard, if you have too many trees, they're too close together, then each tree doesn't produce as many apples. But if you don't have enough trees, you're also could have taken advantage of the space, ooh, I have a big field, one apple tree. Why didn't you plant more than one? There's enough space for more than one. But eventually, they get too close together. So the question is, how close should you plant them together? And mathematics can help us figure that out. So again, we want to find maximum apple production. Okay, so we want to find, and sometimes they use the word yield when they're talking about a crop. So we want to have a maximum yield. So we're going to see, how do we write in words an equation for this? So, does it make sense? The number of apples per tree times by the number of trees would give you how many apples in total you produced. So this is the part that you have to read the question and understand the situation. So how many apples am I going to produce? Well, however many apples per tree times by my number of trees will give me my total number of apples. Now I need to have the algebra. And just like profit questions, these ones give us a starting point. Number of apples per tree at 320 trees. So we have a starting point. If we have 20 trees, we get 300 apples. If we add a tree, so here I'm going to let x equal number of trees added. So if I add one tree, or if I add x, then it gets more crowded, and the apple trees produce 10 less apples. So every time I add one tree, I have to subtract 10 off the number of apples. And this is our setup. Now, complete the square, multiply it out, find the vertex, and you can solve this question. Okay, we're going to do the setup for the next one. And then I'll give you the rest of the class to start solving them. I'll put the answers up on the video so you can look at them later. Is this the next one? Yes, good. So we've got a river, and a rectangular fence is to be built alongside the river. You don't need any fence along the riverbank, and you have 80 feet of fencing. So again, whatever amount you use here, you will also use here. And if you had 80 to start with, then this side will be what's left after you've used up 2 x's. We want to find a maximum area, so we need to make an equation that's area equals. Area is length times width. And it's kind of unfortunate because I think these are exactly the same numbers as we used last time. So after this, it's going to be identical to the question we did yesterday. Okay, so there's the setup. Yesterday it was against a barn. Today it's against the river. Two more questions for our setup. A ferry charges a fare of $10 and carries 300 passengers. The manager estimates that the company will lose 15 passengers for each $1 increase. So again, can you see that this is like a profit question from before? We want to find the greatest income, right? What does our income look like? Well, it is the price times by the number sold. What's our price? It starts off at $10. The number sold starts off at 300. It says that if you increase the price by $1, so then I'm going to say let X equal the number of price increases of $1. So my price goes up by X. Every time I increase it once by X, I lose 15 people, so I have to subtract 15 times X. There. And again, we've done our setup. And finally, our last question, find two positive numbers whose sum is 14 and whose sum of squares is a minimum. So, sum of squares is a minimum. And what does that mean? It's going to be your first number squared plus your second number squared. That's what a sum of squares would mean. And we want this to be a minimum. So how do we go about finding this? We have two numbers. Well, let's make our first number x. What would be our second number? Close, very close. Okay, so find two numbers whose sum is 14 and whose sum of squares is, so if this was 8, what's this one? Two numbers whose sum is 14. If this one's 8, this one's 6, this one's 7, this one's 7. This one's 1, this one's 13. How do I write that in algebra? 14 minus x. So then we can change our written thing out. First number is x squared plus second number is 14 minus x squared. You're going to have to multiply this out, combine your like terms, and then find the vertex. So I'm going to leave those for you. On the video though, I'm going to have the answers so you can look at them at the end. You'll have to pause the videos when the answer comes up because they're not going to be on there long enough for you to write them all down.